Okay, so optimization. Here's what I've got. Question number 5. I have this satellite dish on the outside. I'll draw it. All right, and it's connected to your backyard of your fence. And your satellite dish is connected to your TV, of course. This is 20 feet long. And going south, as they shared, because they originally said it was going west, 20 feet west, 12 feet south, is your TV. Woohoo! 83 inches. Now you're wondering, do I have an 83-inch TV? I do not. Okay, I would love one, but I just don't. So now what I'm going to do is I'm going to make a full rectangle here as best I can, and draw another boundary line. Okay, because it says 8 feet south of the satellite dish represents the boundary. I'm going to say 8 feet from your interior to the exterior of your house. Okay, and we're going to assume that this is rectangular. And you're like, this is not drawn to scale. And you're somewhat right. You know what? I'm going to make that more scale-ish. Okay, so 8 feet would look more like that. Okay, so there's 8. That means this would have to be 4. Okay, now here's where your engineering skills come in. The cost for an outdoor cable to connect this to this end is expensive. Okay, it's $10 a square foot, whereas the indoor is a little bit cheaper. It's $6 a square foot. Okay, and what some people will say is this: they'll say, you know what? Let's travel cheaply along the inside of your house, okay, to here, and then pay the rest of the exterior piece with this just more expensive piece, just this last remaining 8 feet. Okay. Some people may want to do the inside real cheap and then pay a ton of money for the exterior. Okay, and that's how maybe a dishonest company may say that your house needs to be wired so they can maximize their profit from that. Okay, or okay, maybe there's a spot somewhere in the middle where you can, and I'm just going to make one up right here, where you can connect your TV, okay, to this point, okay, along your boundary, okay, and then do the exterior part right there. Okay, now maybe it's somewhere on this line. I have no idea what it would be. I know that if I read it from, I'll just say going from east to west, okay, I'm just going to call this X. And that would mean that if this is X, and this whole length is 20 going straight across from left to right, because that's what this is, this side is going to be 20 minus X. All right, now, here's what I got. I've got 2 distances that I got to find, okay? Your 2 distances are this one with a special wire. I'm going to call that D1. And this guy here is my second distance. Okay, so, and here's what I know. Okay, I'm going to write it up here. The cost, okay, is going to be equal to, well, the interior cable is $6 a $6 a foot. So I'm going to say 6 times whatever your D1 distance is, and it's going to cost $10 times D2. Okay, $10, whatever that distance is. All right. Now, what you'll notice is that every problem that we've done has involved some type of special formula. All right. And if I take a look at these D's, okay, what is this respective distance of? Well, it's of that cable, but I'm using it as a form of a representation of your right triangle. Okay, this is some type of right triangle here. So this side is 20 minus X. Vertically, this is 4, because again, we said this was 8, and this side will match up, that's 4. the other side. And so if I want this distance, I'm going to use Pythagorean theorem. I'm going to say that 4 squared plus 20 minus x squared, okay, is equal to my d squared. Okay, so to solve for d, I'm going to square root both sides. And I only want the positive version, and normally there's a plus minus. But yeah, I only want the positive version because we only have positive distances. So that's 16 plus, gosh, in the inside, I'll multiply that, I guess. That is 400 minus 40x plus x squared. Okay, and let me make that a little more clean. Thought I could fit that all in. Okay, plus x squared equals d, actually d1. Okay, so I'm going to write that in kind of small. It's 6 times. Okay, and maybe I'll simplify this. It looks like x squared minus 40x plus 416. All right. Let me just check my work. There's a 16. 400 minus 40x plus x squared minus 40x. That looks good. Okay, now I have to do the other one too. Okay, so that's 10 times, and I have to represent this distance in terms of x. Well, let me write it right next to it. I know that x squared plus 8 squared equals this distance here squared. And so if I square root both sides, and I'm again only use the positive version because I'm using distances, that's x squared plus 64 all square rooted. And I'm going to put that in the second spot. Okay, and then I'm going to stop. Okay, so that is the kind of obnoxious setup for this system. Okay, and don't forget the 6 and the 10. Those are the respective prices for these distances of cable. All right, so pause this if you need to reflect on it. Check your math. I'm going to check mine again. But I think I'm in the clear. I think I'm good. Okay. All right. Now, what do? Same thing that we always do. We're going to do c prime of x. Okay. And I'm going to take the derivative. Okay. Now, this is not going to be fun, but let's see. Remember that when you take square roots, this is just what I do. I just know there's the 2 on the bottom, and I'm going to recopy this inside. Oh, brother, don't. Okay, good. All right, and then on the top, remember, once you put this in the bottom, you have to take the derivative of this bottom piece, okay? And so when you take the derivative of that, you get, let's see, x squared, which is, derivative of that is 2x minus 40. Cool. All right, and same idea over here. This guy is going to go on the bottom. Okay. Don't forget your 2, okay? Because again, I'll write this on the top. The derivative of square root of x, you just know is 1 over 2 square root of x. Okay, and then remember you have to take the derivative of the inside piece. Okay, whatever's inside by chain rule. All right, now taking the derivative of this will now give you 2x. Okay, so I could probably clean this up a little bit better, even though this fraction plus another fraction is going to look crazy ugly. Okay, so here's what I'm going to got. I'm going to put this on the bottom. Okay, and the 6 and the 2 are going to go away. That'll give you a 3 on top. And I can do this. Don't mean to be overly tricky, but I'll just be fine with that. The 2 will go away. Okay, that becomes a 3. And just for making things easier, this will be 6x minus 120. Okay, 3 times 2 is 6x. 3 times 4 is 40 is 120. And then over here, I've got 5 times, because those will reduce, times the 2 will give you 10. So those 2's basically wash. Okay, so 10x all over x squared plus 64. Now, sometimes they say, hey, you don't have to simplify, and you really don't, okay? Like, if you had just left it like what you saw up here, okay, that's certainly good. However, I'm going to have to put this in a graphing calculator, okay? Because, again, I have to set this equal to 0. And, in fact, I don't want to rewrite all that, so I'm going to erase this guy. And watch this. I'm going to set that equal to 0, so that is less for me to correct. Okay, less for me to write. All right, so just to make sure I got this right, just verifying 4 squared is 16. This looks all good. As you take that derivative, this goes to the bottom. Okay, and then take derivative of the inside, that goes here. The 6 is from that spot. 6 will cancel the 2. You got the 3. I think that we are good for as ugly as that looks. And the same thing for that guy. It's always good to check your work because these are messy. And if you mess it up in any little bit way, throws everything off. Okay. All right. So here's what I got to do. I got to put this in my graphing calculator. So I'm going to clear something out. Okay. I'm going to just unhighlight this. I'm going to keep my work. Go to my graphing calculator. I'm going to clear both these out. Clear and clear, clear. Oh. And here's the bad thing. I thought I already had to put it in there, but I did not. So I'm going to have to be careful here and get that back. So that's 6x minus 120 in parentheses. Here's what I'm going to do. I should have you pause this and just try it on your own. In parentheses, 6x minus 120. Okay, divided by. I should just write this down with a pencil. Okay, sorry to make this delayed. 6x minus 120 all over the square root of x squared minus 40x plus 416 plus 10x over x squared plus 64. Okay, so I wrote that down. I'm going to go back to my calculator. That's the first piece. Okay, we don't have a common denominator here. It's just, it is what it is. And let's see, divided by the square root. And this gives me x squared minus 40x plus 416. Oops. All right, that part of the fraction looks good. Assuming all of our work is right, and I'm going to move it over and out of the square root bar and then add the second piece to it. So plus, and then I have to write 10x, okay, so 10x, okay, divided by the square root, so second square root bar, And this is x squared plus 64. So x squared plus 64. Okay, that's how you see it. I'll tell you what I don't like. I forgot. Oh, that's okay. I thought I had forgot parentheses, but it's actually underneath the square root bar, so I should be good. All right, let's hope this graphs nicely. So I'm going to hit graph. And it looks like it crosses somewhere over here. Okay, I know that the distance has to be somewhere between 0 and 20. Okay, and we'll take a look and see what this is. I got second. I have trace. Okay, and I'm finding a 0. And so I'm going to move up a little closer to it. Okay, and I'm just going to hit enter one time. And then I'll go a little further. And I'll hit enter again. Okay, and when we do all of this work, we'll hit enter a third time. And my 0 is 5.665. All right, so let me write that down for myself. X is equal to 5.665. I believe that that is my only 0. And just to check to make sure, because I know my domain really is the distance that X can be. It can be anywhere from 0 to 20. And what I'm going to do is go to my window and just make sure that my X max, as I go to 20, will not show another root. So let's just make sure there's only one. And there you go. Okay. All right, so we will quit this. And I'll go back to my PowerPoint. Punch that up. Okay, and we're going to finish this. Now, this finishing piece involves a couple items. So first, let's decide what X is. X is 5.665. It is rounded to 3 place values. Okay, past the decimal, so that's great. And I'm going to do two things. Okay, one, I'm just going to verify that this is still a minimum. Okay, I know that gives me a 0 for X, and then this is C prime of X. Okay, and I got to pick something smaller than it and something bigger than that. Okay, so gosh, like I don't want to plug stuff in. I'm sorry. There's 4 and there's 6, and we're going to see what we got. Let's do this. If this is already stored in Y1, okay, let's just go back to our graphing calculator and do Y1 of 4 and Y1 of 6. Okay, so watch how easy this will be. I'm going to escape this again. I'll keep what I got. I'm going to go to my graphing calculator. And to get your, let me clear this so it's easy to see. Yeah, I want to clear it. If I want my Y1, I'm going to hit alpha trace. Alpha trace usually does the trick. And then I'm going to put in, I think I said 4. Ooh, not 43. Okay, so there's 4. It gives me a negative value. So I'm going to write that down just because it's not going to be easy to remember. Negative 1.3487 or 349. Okay. And then if I do second enter one more time, I said 6 also, 4 and 6. Okay, it gives you 0.23. Okay, the fact, I'm going to write 0.231, that I have sign changes for each of those is a fantastic thing. So I'm going back to my PowerPoint. Okay, I'm going to hit this guy so that it works. 4 is negative 1.349, and this is 2.31. Sorry, 0.231. Okay, and so what this means is we're going from negative values to positive values, and because of that, we have a minimum. Okay, and so we have a minimum. relative minimum at x equals 5.665, okay, since the values move from, not more, darn it. Move, new color, okay, from negative to positive, okay, for c prime of x at 5.665. Okay, and that's a good representation that's showing it's a minimum. Okay, now here's the last thing you have to do, and this is going to be more of a pain. Okay, we need to know what the final cost is. Okay, this just says there's a relationship that tells us that the minimum should be at x equals 5.665 from east going to west. Okay, so that's what they're saying about this. This is some other value, but what I'll do is I need to figure out what the total cost is. And I'm also going to figure out the cost at the two boundaries, which is when x is 0 and 20. Our domain of what x could be is, it could be 0, and it could be as far as 20. So I will test those as well. Okay, and we'll figure out what is the best representation for a minimum cost. And so now I'm just doing C of x. Okay, I'm not doing C prime of x. And you're like, did we have that in our graphing calculator? And the answer is you did not. Okay, so let's make sure we have this written down, because, well, actually, you have a calculator is probably handy to the side, but mine is not. Mine is on my computer. And I know what you're saying, like, how can I get one on my computer? And my response is you'd have to buy one. But once you got it, I'll tell you what, you will host the most amazing parties math parties every Saturday night. Okay, math parties are huge when you become a senior in high school and beyond. And once you got that on your computer to share with everybody, you are set. Okay, so I'm going to clear this. And in my derivative, yes, I do. I'm going to go to, I feel bad like typing that all in and erasing it, but I really don't need it, but just for nostalgic reasons, I don't want to get rid of it. So this is, let's see, x squared minus plus, I don't want that, 40x. I have a touchscreen on my computer, so I'm just typing it. Cool. Okay, and then plus 10 times the square root of x squared plus 64. Okay. All right, that looks good. So that's just in Y2. And so I'll hit enter, and I'm going to go to our home screen. Second, quit. Okay, and now I need Y2 of those three values. Okay, so Y2 again is alpha trace, and Y2 is not this guy, it's actually the 2. So I'll click that. No, sorry, alpha trace, Y2, and then I'm going to plug in first 0. Okay, that's a pretty expensive price. Okay, at 0, I have $202.37. That's what it would cost you. Okay, and if I do second enter and I plug in 20, that was the other boundary. It's even more expensive. Okay, 239.41. Normally you round to 3 place values, but because we're actually answering this in context, the dollar amount is fine. Okay, And let's see, the last one was 5.665. So I'll hit this one more time. Second, enter. Let's backtrack a little bit. 5.665. Oh, look at that. You know, the quality engineer would save someone, I don't know, 15 to another 40 to that, what, 13 and 40, another 50 bucks, you know, quite a bit of money. Okay, so if you're an engineer, you can maximize your savings, okay, by minimizing the cost of wiring your house. Okay, so there you go. Let's go put this back in, and we will be done with this problem and done with this lesson. So again, when you plug in 0, you got 202.37. That was the cost of that. 5.665 feet away would provide a cost of 187 points. I want to say it was 3.2. I'll check to make sure in a second. And 20 was 239.41. Okay. So that is it. Okay. So that is the minimum. Okay. That is the minimum cost. Do you have to check these? You do. Okay. And it's not hard to do. If you have to do this one to begin with, then it's easy to do otherwise. But you can see this is a very involved question. Okay. Once you set it up, which is the hard part, okay, then you have to do a derivative, which is hard to make clean. It's further hard to make clean when you put it in a graphing calculator. Okay, so beware of that. Take your time, check your work, and you should be good. All right, that is it for optimization. This is your assignment. It doesn't mean that all of them are as nasty as that number 5, but you can see we got a couple of practice. Okay, if you have any questions, let me know. You have a great night. We're almost done with quarter 1.